Okay, let's have a look at our last of the laws of motion that we're going to look at, and this is Newton's third law of motion. This one should be pretty quick, so let's get going. So Newton's third law is one that you will have heard stated quite often, and this is that every action has an equal and opposite reaction. When we're talking about this in terms of forces, it means that our forces are always acting in pairs, okay? And it's important when we look at forces to be able to identify these force pairs and be able to look at one which is an action force and a reaction force. If we consider when we lean against a wall or pushing against a wall in this case, as we push against the wall, we have the force of our hand or our finger pushing against the wall, which is our action force. Okay, and then we have the force of the wall pushing back against our hand, which in this case is our reaction force. Okay, we know that these forces exist, as we talked about when we first talked about forces, because our finger doesn't push through into the wall. So as much as we're pushing against the wall must be pushing back against us to stop our finger from moving in. This little animation down here illustrates that quite well. This is using two different spring balances. As spring balance A is pulled away, spring balance B, the amount of force acting on it is exactly the same. So A pulls on B with the same amount of force that B pulls on A, and therefore the action force and the reaction force are always equal. So what does this mean for us in reality? We can see Newton's third law in action quite a lot when we talk about space. First things first is how we actually get there. With rockets, what we do is we propel a large amount of gases out of the rocket engine. This is the large combustion reaction that forces the gases out. So the gases are being forced down from the rocket. And as this occurs, this causes a reaction force in the rocket, causing the rocket to move up. So we have the thrust, which is our action force, okay, and then the lift, that is our reaction force. We can have a look at this ourselves just by blowing up a balloon. As we release the air from the balloon, the air is pushed down, okay, which is our action force giving us thrust, and then the balloon will move upwards. So these are contact forces, the air pushing down and pushing back against the rocket, but we see the same action-reaction when we see non-contact forces, and we can see this with satellites in orbit. So the satellite will be attracted to Earth with the force due to gravity being attracting to Earth. And the Earth is going to be attracted to the satellite with the same force, okay? It's easy to think that this isn't the case because we think, oh, they've got really big masses. But this is exactly it, because the acceleration that we see, the change in movement due to this force on, is actually going to be very, very minimal when applied to the massive size of the Earth compared to that of the satellite, okay? But this holds for all force pairs. There is always an equal and opposite reaction force to every action force that we see. Okay, so that is that for our Newton's third law. Next up, we'll just look at applying Newton's laws to car safety.